Well, thank you, everyone. How's everybody enjoying Trailhead DX so far? Wow, awesome. Glad to hear that. Fantastic. I'm having lots of fun as well. So what I'm going to show you today is how you can make your app smarter. What if you could make your app smarter using AI? And what if you could do that without having a data science degree? I know I hated statistics in school. I took some data science stuff. It was terrible. Didn't do well in that. So I'm going to show you how you can do that today, how your developers can do that as well, and do it really easily using things like point-and-click tools. Because you doing AI is normally really hard. We make that really easy for you to be able to do that and to be able to add that to your application. So before I get started, just a little bit about me. My name's Chris Kemp. I'm a director of emerging technologies, so I cover some of the things we're going to be discussing today. Einstein Platform Services, so Einstein Voice, Vision, and Language. We also cover blockchain as well. Anybody excited about the big blockchain announcement? Awesome. Yeah, we cover that as well, so exciting stuff. And we also cover big objects as well. So for folks who don't know about big objects, you can store big data, hundreds of millions, even billions of rows in Salesforce, and do that in a very, very cost-efficient way. So I've been in Salesforce for 10 years in the Toronto office, and loving being here. Been to a few Trailhead DXs now, lots of Dreamforces, so it's always great to be here. And normally I make a joke on this slide, the forward-looking statements about how if you have trouble sleeping, go ahead on our website and read this. But actually today we're going to be talking about Einstein Voice, which is not GA yet, so do keep that in mind for making your purchasing decisions. So AI assists us with little things every day, and we don't even realize it. So for instance, I get out of bed. As I mentioned before, I'm in Toronto, so I'll actually go to my device, my Google Home device, and say, hey, what's the weather going to be like today? And in the winter, of course, it says something extremely cold temperature, and I swear. And then, of course, I think, OK, I'm not walking into work today. I'm getting in my car. So as soon as I get in my car, then I go to Google Waze or Google Maps, something like that, and AI helps me get to my location that I want to go fastest. But of course, before I actually go there, well, I've got to get a coffee. So what am I going to do? I'm going to actually go to my app, and it's going to be able to suggest to me, based on the coffee that I've had before, some new coffees that they have that they recommend to me. So, oh, great. Well, I need my caffeine. Haven't tried that before. Let's do that. And AI powers all of that. We don't even think about it anymore. And in fact, your customers are actually expecting that in the apps that you create, whether those customers be internal or external. And in fact, IDC says that 80% of apps will have AI by 2020. So for those who don't know what year it is, that's next year. And are 80% of your apps AI-driven? Probably not yet. So I'm going to show you today how you can do that and make that really easy. Then the second half of the presentation, we're going to talk a little bit about how you can, for instance, structure your AI organization, why it's a little bit different from development, and what you can do to get started. But the reality is that AI is actually difficult. And the reason it's difficult is because, by the way, has anybody tried doing things like Google TensorFlow, things like that, to be able to set up AI? Yeah, how was that? Not very easy? Not so much, yeah, exactly. It's not easy, and often requires a data science degree, especially to build the models on the back end. So it'll get you partway there, but there's that huge rift of things that you need to do to be able to get that up and running. So it can be very difficult, but it doesn't have to. Because now we've got things like Einstein that are able to help you with that, and you can use an API to do that, and you don't have to be a data science to be able to create those models. And I'm going to show you some of that today. So today we're going to talk about 3 different ways you can add AI to your app. In fact, 2 different ways, and then 1 that's up and coming. 2 today, 1 up and coming. So using things like image recognition, natural language processing, and voice recognition. So let's start out with image recognition. So first off, what is image recognition? How does it work? Well, first off, the reality is that there's lots of images out there. In fact, IDC says there's 1.2 trillion photos in 2017 that were there. And in fact, I told a colleague of mine the stat, and he said, oh yeah, I've got a teenager. They probably created about 1 trillion of those. So I don't know if that's true or not. Maybe if those who have teenagers might be able to attest to that, but apparently there's that many. I would say probably now by 2019 there's around 2 trillion. So that's a lot of images. And if we're not getting any information out of those images and the unstructured data that sits there, then that's wasted data. So we can use something called Einstein Vision to be able to get, or image recognition in general, to be able to get some data out of those images. So firstly, this uses a convolutional neural network. And basically the way that works, I'm not going to go too deep on this. Basically the way that it works is, first of all, an image is made up of pixels. So what it does, it analyzes all those pixels, does a bit of edge detection, and then takes those edges and then makes it into object parts. So those object parts might be, let's say, a tree, It might be a beach, it might be some sand, and it might be an ocean. And then what it does is it puts those together and it detects objects. So now it can tell that entire scene is actually a beach scene based on what it's detected through those. And we typically see 4 different use cases, the first being image recognition, so simply asking, what is this? And it being able to tell you that's a beach. So the second is object detection. So perhaps I take a picture of, let's say, a shelf, and it can go and it can actually take that and tell me all the different products that it has on the shelf, but more importantly, it'll tell me what products are supposed to be there that aren't there, or what products are in the wrong spot. So it can do some interesting things based on that. We also have brand detection as well. So brands want to know, for instance, on things like Twitter or Instagram or other things like that where you can post pictures, hey, is a celebrity going, and are they posting a picture of my product so I can interact with them? So we can do that with image recognition. And then finally, visual search. So you probably had this where you go up to someone and you say, hey, those are really cool shoes. And then you take a picture of the shoes, and then you can go online and it'll tell you these are the types of shoes that those are, or I don't really know what it is, but these are really close, and you can go and buy that. So that's one way. These are different things, different use cases that you can use for image recognition. So next, we're going to talk a little bit about image recognition and how you can actually do that. So the first thing is you need to build a custom model. So in the example that I'm going to show here, we're going to create an app, let's say based on our mobile phone, that we can give our customers so they can take a picture of a fridge, and it's able to tell them, is that refrigerator a 2-door refrigerator or a 3-door refrigerator? So to get started, we've got to build a model. We've got to actually show Einstein Vision what a 2-door refrigerator and 3-door refrigerator look like. So we upload, let's say, 50 images to start with, 50 images of each 3-door and 2-door. So we label those 3-door and 2-door. And then what we do is once we've done that, we can train Einstein Vision on what that looks like. It'll go take that, do all those cool things we saw with the neural networks, and then build a model. So now that we've got a model, what we can do next is we can have our app so our customer can go and it can take a picture of that refrigerator, and then what that'll do is it'll just be an API call back to Einstein Vision, and it will return, I think that picture you took with 85% confidence, I can tell that that's a 2-door refrigerator. So again, not a great example. It won't be a mind-blowing app if you create a refrigerator door app, but you can think of a lot of really cool use cases in that. And one that I want to highlight is very personal to me because I had an issue with my internet a couple of months ago. Who's had an issue with their internet before? Yeah, like everyone, right? And then of course I spent like half an hour on hold, and then I talked to someone, and the customer service rep walked me through, hey, look at your cable modem, tell me, is this light on? Is this light on? What does that say? So 10 minutes later, what I figured is, hey, I could actually use something like Einstein Vision, so I can take a picture of my cable modem, and it can tell me, well, there's that red light there, and those lights aren't on, so go to this, reboot your cable modem, and you're ready to go. I wouldn't even have to spend that 45 minutes of my life that I never got back, and that would have been a great experience for me as a customer to be able to do that, and of course for that customer service rep to not have to talk to me for 20 minutes. So image recognition has a lot of impact, but what do we do about text? So text, we've got a lot of that. We've got things coming in through survey data, we've got things coming in through chatbots, we've got things coming in through communities, and there's lots of unstructured text out there that we can't get information from. And Einstein language gives you the ability to do exactly that. So again, using a neural network, this time our current neural network, it'll actually go analyze that speech that you've got and the different words and how they relate to each other, and then come up with a couple different outputs that you can use as use cases. So the 2 biggest ones we see are intent and sentiment. So intent being, based on the information that I've got, I can categorize that into, let's say, a handful of different categories. So whatever new text I come in, I can categorize in one of those, let's say, 5 different categories. We've also got something called sentiment analysis, where we can go and we can tell, is that piece of text positive, neutral, or negative? So again, how do we make that actually happen? So first off, same thing as before with the images, we actually have to create a model to be able to do that. So for our intent model, we might create 3 different categories: shipping, billing, and product. And then we train it with a bunch of data. So we upload a CSV that's got, let's say, 50 of each of those, so we can show Einstein what that looks like. And then we've built our model based on that. But the great thing is, intent, you actually don't have to build that out. That's something that already exists, that's pre-trained for you, that you can use. So if we want to do a sentiment prediction, we can actually just send in a piece of text, and Einstein will tell us, is that positive, negative, or neutral? So now we've trained that model, and we've got that pre-trained model. And then so the next thing we can do is we can upload some text. So perhaps in our app, let's say this is Salesforce. Again, it's an API call, so this can come from Salesforce, it can come from mobile app, it can come from something on-prem. It doesn't matter, it's an API. So we've got that information, and let's say it's coming from a case, and somebody complaining, I'm tired of waiting, where are my shoes? So of course, now Einstein goes and consults that model that I've just created and says, with 73% accuracy, I believe that this is a shipping issue. But it's also able to tell me what the sentiment is. Is that negative? So with, again, 60% confidence, it says this is something that's negative. So again, a simple real-life example here would be, let's say, a community that I have, or perhaps survey data. And we actually have a customer, retail customer, that uses this to analyze survey data. They literally had tens of thousands of surveys that were coming in saying, hey, what did you think of our service? Free-form text. And they would actually have people, these poor souls, and they would go and they would pour through all that data. They'd have to categorize all that data. They'd have to say, is this positive, negative? They hated their lives. And so this is not a fun job. So what we can do is we can use Einstein language to go do that. So anytime any of that information comes in through that survey data, it's able to tell which department is this for, and it's able to tell is that positive, negative, or neutral. But more interestingly, we can actually map that over time using something like Einstein Analytics. So we're able to tell over time, are things getting better in this department, or are things getting worse? So we can do some really interesting things with some of that data that we're getting from Einstein language. So finally, we talked about two things that you can use today. Einstein Vision, Einstein Language. We're now going to talk about voice. And I know lots of folks have heard about voice. Again, this is something you can do today. It's not generally available. It's currently in pilot. But it's really interesting because it's going to be a paradigm shift in how we do things. And I know when I started using computers, it was all command line. I was using a Tandy TRS-80. You had to type things out. It was terrible. Finally, point and click came along, so I'm able to go. I can point and click, and I can get things done a lot faster. But then, of course, now everybody has a smartphone, so they can go use their smartphone and use their touch interface to do that. But in the future, we're going to have the ability to do all of this with your voice. And this, of course, opens up a lot of new opportunities for us to interface with computers, especially if, let's say, you're a surgeon and you're elbows deep in a patient, and you've got to add, let's say, a note or a follow-up or something like that. That's going to be really difficult for you to do without scrubbing in and scrubbing out to take that one note down or get somebody to do that for you. So it's something that you can do with voice. But more interestingly, a use case that I see we're going to talk about in a second is for field service. So there's a lot of things going on behind the scenes when we're talking about voice. Again, a lot of data processing, a lot of AI going on behind the scenes, because we can take that input, whether it be from a microphone, smart speakers, a phone call. We use actually a lot of different models for this, not only to be able to tell what's that voice saying and being able to transcribe that, but doing things like name entity recognition, so picking out names, dates, things like that, and also just understanding the whole context of the conversation, so using something like NLP with intent to be able to get the idea of what's being said. And then finally, we want to do something with that, so we can do a record update on something like that. So an example that I love to give is field service. So field service people, they're out in the field, they're doing things, fixing stuff, all is good, and then what happens is they go back to their van, they put away their tools, and then they sit there probably for 20 minutes taking notes on what's happened, probably pen and paper, who knows. And then they go and they drive off to their next appointment. So what if they could, while they're putting away their tools, just put their phone there, hit record, start taking their notes so they can say, hey, the next person who's coming needs to order this part. I'm going to be on vacation, reassign this to Sandy, who's going to be there next week, and let her know that she needs to do this. And now they can do that. By the time their tools are away, they can just go and drive away. They don't have to take notes, so they can be a lot more efficient in what they're doing. And it's easier for them. So lots of interesting things that we're going to be able to do with voice in the future. All right, so we talked a little bit about a few different ways where we can do this. So that's the, what can we do it? And we talked a little bit about how you can do it and how this works behind the scenes. So I want to talk a little bit about how folks here, especially people like managers, can actually have this happen in their organization. So there's a few different things with AI. And again, as I mentioned, you don't need a data scientist to be able to do this. But if you want to create a data scientist or somebody who can do AI from a developer, this is actually very different than what a developer is really used to. So it's a little bit of a different paradigm. Things aren't black and white. There's a lot of gray, and I'm going to explain a bit of that. Secondly, we need the right organization and structure as well. Again, it's a little bit different than your general coding, so we're going to talk about a few considerations there. And then finally, getting started can be difficult. Lots of people go, again, they do data science courses on Coursera, things like that. It's a lot of statistics, a lot of things that you probably don't need just to get data science done. So we're going to talk a little bit about that. So firstly, let's say we're creating an app, and it's able to detect if what we're taking a picture of is an apple or a pear. So I go and I train it on a bunch of red apples. I go and I train it on a bunch of pears, all on white backgrounds, very nice marketing pictures. And then a customer goes and sends it this. It sends it a green apple. It sends it on a green background. Now, image recognition, Einstein vision is really confused because it's never seen a green apple, and it's never seen anything on a green background. So it has no idea what to do with this. So this is something different for developers because, again, things aren't necessarily black and white. There's a lot of gray. Because what we actually need to do is we need to create what's called a representative data set. So I need to give it a whole bunch of different apples, both green and red, on a bunch of different backgrounds, and a whole bunch of different pears on different backgrounds. And now, when I go and I make my prediction, it's able to know, OK, well, I've seen this before, and so it's able to detect that that is actually, in fact, an apple. But what's really difficult for developers to get their heads around at first is that things, again, aren't black and white. So when I actually do that prediction, it's going to tell me, well, it's a green apple. I'm pretty sure it's an apple, but it looks a little bit like a pear. So it says with 83% accuracy, I think that this is an apple. So for a developer, this isn't if, then, else. This is 83%. What do I do with that? How do I create that threshold? It's a little bit more difficult for them to be able to figure that out. So it's something that's not obvious to a developer all times. And really, there's a lot of different considerations, especially for managers or people who are starting an organization, that need to take when setting up an AI organization within their company. So first off, we've got things like model creation, which we covered, but things like model tuning. So we're going to create that first data set. Maybe we upload some test data. How do we make that better over time? But once we do that, how do we create model governance to make sure that when we go and we try and make that better, that it actually is getting better, not getting worse? How do we go and test that and use things like we do with CI/CD to be able to do that? How do we gather that initial data set? So that's again something that's a little bit difficult. And then how do we create the analytics and KPIs from the business to say, hey, what percentage of confidence do we need for that apple and pear to be able to decide what it is? What's acceptable to you? But also the enabling services is really important because AI is fairly new and people don't know this very well. So we've got to do a lot of things around educating others. We've got to keep on top of the research because, again, this is always changing. And we've got to incorporate things like best practices. But everybody's pretty used to that in normal things that we do within technology. But what's really interesting is the ethics part. And this is really different because what you can do is you can create models that are actually biased. And that's a really, really bad thing. So we actually announced today, you probably heard that in the keynote, that we actually have a trailhead that you can go and you can do to be able to help you get started on that, understand how to be able to do that in a way that's ethical and create those models. So please do go check that out. And when you're structuring your AI organization, there's a few different considerations you have to make. So first off, do I build internally, hire, outsource, or acquire? So, so you can either get developers, try and create them into these AI experts. You can go hire people outside who have already done this. You can outsource this, so get a partner to be able to help you who's done this before, or you can acquire a company. In fact, Salesforce acquired MetaMind, a company who does the things that we do with Einstein language and vision. And they actually took a lot of this. They did a lot of training across the organization to help everyone get up to speed on this. So it was really interesting to see how they did that from an acquiring point of view. Then do we do this in a centralized manner? Or do we align people with line of business? Do we farm them out so there's one person in each line of business so they're able to understand the business better? Or do we centralize it and just go through each of those different projects and then bang through that? And again, you probably already do this in your organization, so you know what works best. Then is this the same group as analytics or separate? Again, often there's data scientists. There's people who know this. Do you keep them the same? Or do you have a completely separate organization for your AI and the rest of your analytics practice? And then finally, of course, who's my executive champion? And a lot of the times, this is something that people don't do. They don't educate leaders within the company. And often those leaders think that AI is a magic wand. You can take crappy data. There we go. Our magic wand is going to suddenly create these great business insights. So we need to make sure that there's some reality plugged in there and that your executive champion knows that and can educate others as well. But the labor market is changing. This is why your developers are going to be very interested in this, because one of the top 10 emerging jobs is AI and machine learning specialist. And again, you'll notice that's different from a data analyst and scientist. And in fact, if you look at Indeed's poll here, or Indeed's study here, machine learning engineer is actually the #1 job for the future. In fact, outranks Salesforce developers and data scientists way down in 22nd. So there's a huge amount of demand here. And if your developers want to take their careers to the next level and do something different, this is a great way that they can go and do that. So finally, how do they go and do that? And again, I see a lot of people, they go and they take data science courses. But I always say, the way to learn how to ski is not to go down the black diamond first, the hardest hill. You go down the bunny hill first, you learn how to do it, and then you go on your way. And so this is a great way to do that using things like Trailhead and also using no-code and low-code platforms. And I'm going to show you something, a tool that you can use to be able to do this using point and click instead of using APIs to get started and learn how to do things like build models. Sorry, just hold off that question for 1 second. I'm just going to wrap up this slide, and then we'll actually take Q&A on the side here. So next steps with Einstein Vision and Language. You can sign up for a free developer org. Basically, you have a bunch of predictions you can use. You can get started using that, and you can do that for free. Again, using our model builder, you can see it's an App Exchange app. It's free on the App Exchange. Go and download that, install it in your Salesforce org. Point and click, you can do that model creation, create predictions, things like that. And then finally, of course, hit the ground running a Trailhead. AI basics right there, you can get started with that. There's another number of other cool apps as well. You can actually train an app to detect cats, tell you what cat breed it is for a cat shelter. And I highly recommend that one as well. That's a pretty cool and fun one to do as well. So as I mentioned, I'm going to take questions just on the side here. So please do stick around. But I hope you learned today how you can go, and without having a data science degree, you can add this intelligence to your apps and be able to create this great experience for your customer, doing that using image recognition, natural language processing, and in the future, voice. Thank you very much for joining me today. Really appreciate it.